All right, so for our next one is 3.9, number 32. Tried to pick one that I thought was a little bit more difficult here. Derivatives of inverse functions at a point. Find the derivative of the inverse of the following functions at the specified point on the graph of the inverse function. All right, so let's take a look at this one. Number 32 says f of x equals, oh, we've got it written up here. I'll rewrite it here. X squared plus 1 for x greater than or equal to 0, and this is going to be our point that we're concerned about. So I can rewrite this as y equals x squared plus 1. And if we remember back to maybe finding, finding what the inverse function would perhaps look like here. So what would y minus 1 or f minus 1 of x? I'll kind of write this as y minus 1 of x. Actually, you know what? I'm going to leave that alone because we need to do something first with that, don't we? All right. If you remember on this is what we want to do is solve for x. So I'm going to subtract 1 here, subtract 1 here. I get y minus 1 equals x squared. And then I'm going to take the square root of both sides, but I'm going to move them back and forth here too. So I'm going to get x equals the square root of y minus 1. Because I take the square root of this side, it goes down to x. I take the square root of this side, it goes down to square root of y minus 1. And then remember what we do with a problem like that. What we then do is, if we want to determine what f of minus 1 of x is, the inverse function, we just reverse the x and the y, just interchange those. So it's equal to the square root of x minus 1. So that's the inverse function. I'm going to fix that a little bit there too. My eraser out here. Go to my pointer. There we go. So that's the inverse function, and that was our goal, is to find the derivative of the inverse function. So we actually got a little bit more work here. So now I need the derivative of that. So I really need, bring this up here now, I really need d dx of the square root of x minus 1. And in this case, I would, as most of you would, I think, I would choose to write this as x minus 1 to the 1/2 power, I think is where I would go with that. So let's go x minus 1 to the 1/2 power. And if I wanted to take the derivative of this whole term, that would be equal to 1/2 times x minus 1 to the negative 1/2. And all of that could be rewritten as 1 over 2. And remember, this x minus 1 to the negative 1/2 just means the square root goes down to the bottom. X minus 1. So that's what my derivative, that's my d dx of the inverse. So that's kind of that first step there, is find that. But now we need, I need to find out what the derivative is at a point. So we were giving the 0.52, and it might help. I don't know if it will or not. I'm going to kind of draw this as best I can on here. It might help us to kind of draw what these functions look like. So let me give maybe 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I'll go a couple in the negative, but we don't have to go in the negative because this is x greater than or equal to that. I'm going to grab a different color here real quick and go to my pointer, go to my color, and I'll make this a black. We'll call black, black will be f of x. So I'm just going to kind of create a little key over here where black equals f of x. So f of x goes back up to here then, so we can kind of talk about what that is. So if x is 0, or right here, 0 plus 1 is 1, so I'm right there. And if x is 1, 1 squared is 1, plus 1 is 2. So it's right here. And at 2, 2 squared is 4, plus 1 is 5. So you can see what this guy is kind of doing here. Hopefully you can see that. It's kind of a half of a parabola here. Okay, that's our f of x. And then if we grab the other side of this function, go to pointer options, I'll go to ink color again. I'm going to grab kind of a blue color this time. And this will be our f of minus 1 of x. All right. And f of minus 1 of x, again, was associated with this guy right here. Okay. So at 0, 0 minus 1 is negative 1 squared, negative 1. I really don't have anything there. However, at 1, I'm good. So 1 minus 1 is 0. Square root of 0 is 0. So that guy's right there. And again, because he's an inverse, we're kind of anticipating that we'll end up with something that maybe is kind of a mirror of that across the x equals y axis. At 2, 2 minus 1 is 1. Square root of 1 is 1. So that's going to go right there, right about there. Kind of hard to draw the dots on here. And then last but not least, let's say at, what can we do that's easy? 3 gives me square root of 2. 4 gives me square, how about 5? 5 minus 1 is 4, square root of 4. And we used 5 up here, so I guess that kind of makes sense. Square root of 4 is 2, so we end up with a point right about here. So we can see that it definitely does mirror what's going on the other axis. So there's f minus 1 of x. And really that last step was we needed to find the derivative of the inverse function at the specified point on the graph. So I'm going to go back to my, actually I can stay here probably. When x equals 5, which is what it is up here, x equals 5. When x equals 5, we can say that y, or f of x, y would equal 5 squared plus 1, which is 25 plus 1 is 26. And what we're really after, though, well, actually, I guess not quite. Y prime, let's see. Y prime for, y prime would be up here now. So y prime is actually this guy right here. It's, again, though, it's the y prime of the inverse function. So I should be careful here as to what we're talking about. Really what we're talking about here is we're talking about y minus 1 prime, which in this case would be equal to, when that's a 5, it's going to be equal to this mess here. So it's 1 over 2 square root of 5 minus 1. All right, so 1 over 2 times square root of 4, which is 2, that's going to be equal to 1/4. All right, so that's what our inverse function is. We don't actually ask that. So this is actually what they're looking for a final answer there. And you can kind of see how I took my time in kind of figuring out what it was they were even looking for there. But if you read back through the problem, find the derivative of the inverse of the following function at the specified point on the graph of the inverse function. So at the point 5, what this is saying is this is our inverse function, and at this point 5, there would be a slope of 1/4. Well, that makes sense. It rises 1 and goes for every 4 of travel. So rise over run. So 1 up for every 4 over. So, and it looks like it is kind of like that. So that'd be 3.9, number 32.